Bem-vindos to one more episode of the Type Theory for All podcast. This is your host, Pedro Abreu, speaking directly from Purdue University in the United States of America in Indiana. Today's episode, I have two friends of mine, Patrick Lafontaine and Supun Abeysinghe. We will talk about their experience learning Coq, and we guide ourselves in a survey that I gave all the 83 students in the class. Unfortunately, not that many answered, but we still got valuable insight. The class was taught by my advisor, Benjamin Delaware, and I was his TA. I would also like to point that Patrick researches compilers and have done work in particular with Rust. Supun, on the other hand, works along the lines of machine learning, more in the context of systems. You'll get a better idea throughout the episode. Well, without further ado, let's get into it! I heard that none of you two actually had prior experience with Coq. Is that correct?
I had like 1 week of experience. So when they taught that OCaml course, CS 3110, I think they did like 1 or 2 weeks where they're like, hey, here's this cool idea of like proofs as programs. And they did an absolute crash course of like, they covered like auto and induction and like data types. And I don't think we got any farther than that. We had like one homework we had to do on it, and I don't think we ever touched it again. But
I'm curious. Do you remember what your impressions were back then? Like, what this is? You know what I mean? Like, if you thought it was weird or if it made sense or what's going on there?
So it was. Luckily, I guess we're doing this whole course in OCaml, right? So, and they dropped us in it. So for a lot of us, OCaml was the first functional programming language we got to use. So for all intents and purposes, like this is what a functional programming is whatever you can do in OCaml. And then Coq is pretty close, at least in terms of like syntax and like the look and feel of it when you're writing these kinds of things. And then after that, it just, like, I mean, they really sell it to you like, here's this cool little addictive game where you can try out different things and you can try out different tactics, and hopefully you can just kind of auto it away, or you come up with like 1 or 2 like nice like ideas to like structure your proof, and then poof, your whole thing works out nicely for you, and then you'll feel good afterwards. So I actually distinctly remember they had one homework, and the homework was a breeze for most of it, and then there was one final problem. One final proof. I don't remember what the proof is. I could probably find it if I wanted to, but and it's everybody got stuck on it for like hours. And this is the one thing, like you go to office hours and the whole thing's packed. There's people out the door, and we're all trying to figure out this one proof. And I remember we're stuck on it, and then I leave afterwards, and I go and I sit down for like 30 minutes after the office hours, and I somehow everything clicks. And I figure it out, and it was like the best feeling ever, the best feeling like of all time. Yeah. Like, oh, I figured out this super hard thing, and now. I mean, in retrospect, now if I tried to do it, I'm sure it was not hard at all.
Yeah.
But like in the moment, like it's like, oh, this is so cool. But I think then afterwards, I never really got the chance to do anything with Coq afterwards. So like, and so all I really remember is like induction and auto, and so I really enjoyed like this, taking 565, because now I get to go a little bit deeper in like, what are we actually doing here? And getting to see the differences.
Dude, I really relate to this joy of getting your proof done. And I'm sure that many of the listeners will relate as well, because it's just such a deep joy. I remember distinctively the day I finished my undergrad thesis, because in Brazil you had to do this stupid undergrad thesis, and I was stuck proving. I had to, so maybe some people will know this, but I was proving that featherweight Java was correct. So featherweight Java is this Pierce paper from back then, and they have some proofs there. So I was doing that proof, and then afterwards I added extra stuff to featherweight Java. But I remember I was stuck with some context bullshit for a very long time, for like months, and nobody could help me because I was pretty much working by myself, because we didn't have really a Coq community in Brazil, like in my university, and I was pretty much just banging my head against my keyboard. And my advisor, he would start getting really angry at me. I'm like, just use an axiom or something. I'm like, no, I'm not using axioms. I want to get all the way through, right? And then this one night, I I finally find a technique and how things are properly done. And I stay up until like 3:30 a.m. until everything goes through. And I remember I was so happy. I was so happy that I started jumping around my house like 3:30 a.m. just celebrating with myself. It was like such a deep joy, and things just click and make sense. It's just so good. That was the moment. That was the moment I decided to do a PhD. No, that's not really true, but it was one of the moments. Okay, bye. So, um, right, 565. How do we transition here? Yeah, so you were saying, Patrick, that you were really happy to go deeper. So you were saying that you were really happy to go deeper and learn actually what we're doing, what we're trying to accomplish here in 565. So what was your overall experience with the course and actually learning cog?
Uh, I think overall, like it's a pretty everybody. I think everybody has overall like a pretty positive experience with this course. Like everybody really enjoys the idea of like, hey, I'm actually going to be able to like write programs and like show that they're correct or that they show that they have these certain properties, which is something that like you really don't get to the sense of when you do anything else. And especially I guess everybody and especially for me coming off of like taking all these other programming courses and like you're writing all this code, especially a lot of my stuff is all C code, and like being always frustrated when you never knew if something was working exactly as you expected it to. Being able to like to do these like to do our homeworks in this in 565, and like when you got to the end of your homework and the everything was green on your editor and like there was no
Yeah,
like admitted sections left, like that was always a good feeling, you know, because you actually knew
Yeah.
that, you know what, things are I did it right, you know. I don't know, do you want something else besides that?
no. That's really great. That's really awesome. What about you, Sopan? What was your overall experience?
Yeah, I think it's pretty similar to what Patrick said. Yeah, so I guess one of the main reasons I took this course is because I was always curious about this stuff. Because in TIAX group, we have this large group meeting where everybody like gives like an update, and we have a bunch of people who do these like core PL stuff, and obviously they are doing some cock proofs and stuff, and they discuss these things, right? So like I don't know, operation semantics, okay, small step stuff like that. I mean, I had no idea about those stuff because I mean I didn't have any background, and but I was always curious, and then once I took this course, and I guess in the first couple of weeks, I guess we covered most of like the fundamental stuff, and I realized, okay, these are some really simple stuff, and also the things they discuss sort of start to make more sense,
Right.
and yeah, it was a nice feeling because it's nice to understand what other people are talking about,
Yeah,
and
right. I definitely understand that feeling. Often enough, you're reading that paper, and apparently they take so much for granted, right? They start talking about this
right,
operational semantics and this denotational
yeah,
semantics and all these rules here and there. Like, what? I have no idea what's going on. Like, and
right,
they just throw it there and say, yeah, this is like all the normal stuff that is already done in the literature in the past
right,
60 years or something, right? And you're like,
right. Yeah,
so
and the thing
yeah,
about like the inference rules, it's a really simple thing, right? The notation and
yeah,
stuff. But
right.
if you don't know it, it looks like Greek. I mean, it has
Alien,
some Greek letters, but
right?
like you don't understand anything, right?
Yeah.
But
But it's
yeah, it
once
was
you
really
learn how
interesting
to
to
read it, right?
exactly. Yeah, yeah. So it was super fun to learn that stuff and finally start to understand some of the stuff, I guess.
And yeah, and I don't know if it applies to you, but then it's just I remember when I was first learning this, and it's just such a concise way to talk about all the all the possible scenarios that your program should behave in order to be the interpreter, right? To do the type checking, and then you learn what are the questions that we're interested in asking here, right? Like type soundness, and then you understand this concept of progress and preservation and why those matter and why we're so interested about that, right? And then all the papers in a way that we've been working through, especially, I don't know, I feel like especially here at Purdue, we are always looking at papers from Popo, from ICFP, from where else, CPP, and all of those rely heavily in all of these details that is already well established in our community, right? So taking a foundational course like this definitely gives you a pretty good and solid groundings on how under in order to understand these papers and what these people are going to be talking about, like some sort of lingua franca where we can all understand each other, right? So yeah, definitely agree with all of that you were talking about. So in our survey that we gave to the students, you guys, we made a couple of questions, and overall, I had a pretty good feeling about how the students perceive the relevance of this course. Although, if they were answering this survey, I think they're already a little bit biased towards, having liked the course and thinking this is relevant somehow for them. But we had a couple of students here that answered the survey that they had no background with functional programming ever before. So Coq was their first time learning any functional programming ever, which was also the case for me as well, which is weird when I think about it nowadays, because like when you're learning Coq, you're already thinking about the proofs and the properties, but then there is this pattern matching stuff that in my time it was just so alien. Like you go from Java and C, and all of a sudden you're in this tiny little core programming languages, and you have to think in all of your algorithms in a completely different way, right? Because uh, there is no for loops, there is no stuff that you're actually used to. Nowadays, I look back and like, oh, come on, for loops is just like an iterator, and it's really obvious how to how to accomplish this with like a fold. But back then, you have no idea. Your mind is fresh, and you're trying to learn this new paradigm. It's like learning a new language from scratch. Like it's more than learning another programming languages. You're learning another paradigm. You're learning how to think about your programs from scratch, right? So things will change a lot, and it's normal to feel that you have no idea what's going on because things are completely different. You're in an alien land. Things are very, very different here. So if you're just learning, if our listener at this moment is just learning some Coq or some Agda or Isabel, I don't know, and they feel kind of lost, it's okay. It's okay. Don't worry. Hopefully soon things will get better. I promise. If you keep trying hard enough, I don't know.
I think though that like hopefully it's slowly probably getting easier and easier to pick up functional programming, because a lot of the popular languages that
Right.
somebody might pick up or might like initially start with, like Python, for example, like Python has pattern matching, like, and
You
Python
call that
has a
pattern
lot of like,
matching? Really?
it has something, right? Come on. It's called structural.
I'm kidding.
It's called structural pattern matching. I don't know, whatever you want to call it. But like, in a lot of these, and like that's the same thing like within JavaScript. And you've got like anonymous functions, which are kind of like in these like closure lambda kind of things. Like you start to see there's some of these things they kind of like percolate their way through the ecosystem, and a lot of these languages are picking up functional programming like techniques. So even if you have like no functional programming experience, like hopefully maybe you've seen a language that has something resembling pattern matching and something like resembling these different like the data structure, these data types, and you have
Right.
something.
Right. Yeah, I definitely get what you're saying. I'm older than you guys, so back in my time, you didn't have that much stuff. Like I remember when I was like halfway through college, Java 8 came out, and then streams was a huge thing. And streams is exactly this notion of iterators, right? Like having maps and having folds over your data structure. Like you can convert your list to a stream, and then you do all this nice, cool functional programming sort of stuff. And I'm like, then I tried. I remember that I already knew functional programming language back then, and then when I was applying this, when I was learning this stuff that was just coming out in Java, it was just so ugly. It was just so ugly because they were trying to get this really nice and well behaved approach that you have in programming language from the get go, and then apply it to a language that it's not like that by default, right? So they have to do some adaptations there. And I'm not saying that the adaptations were bad, it's just that Java does not provide the same paradigm that these functional programming languages do, right? So I remember that I would joke with my friends back then that I would be like, yeah, functional programming is like they're just trying to imitate and mimic the really good ideas that you have in functional programming, because Haskell and Scheme and OCaml have shown that they can really shine given the proper use, right? And then these other languages are slowly taking these ideas in them. So, for example, when algebraic data type was created, it was like this little really small functional programming language that was just for research purpose, right? And then this idea was just so beautiful and so simple. And pattern match comes from algebraic data types, right? Like you have pattern match as an eliminator for your data type. So like you have data type, you have algebraic data types, you have pattern match, right? And nowadays, if you're building a new programming language, like a modern programming language, you will have algebraic data types. It's kind of like really creeped into normal programming languages. Like Rust have a notion of algebraic data type, right? And that's really exciting. That's really exciting because in functional programming language, you can test all these different ideas, and they slowly creep into the more what's the name, like normal, more used, like more widespread programming languages out there, like Java or TypeScript or Rust, right, and Python and all of that. And that's really exciting. That's really cool. That's really cool. That's why we are excited about doing this sort of research, right? Because we get to study this stuff and show that they are well behaved, and then you get to apply them in practice, and they show that they are really useful and leads to really elegant and beautiful code, right? That is good to reason of and remain modular and all those cool properties that a good programmer cares about, right? Anyways, do you guys have anything else to add on that end?
I mean, isn't this is kind of why it's like exciting to be doing programming languages research right now, right? Because, well, I guess for our advisor TR, like one of the things he's kind of known for is his work on Scala with Martin Odersky, and like there's been a lot of interesting research with Kotlin. Like so, both these like languages that are based off Java, and that they have in some sense some kind of strict interoperability requirements. They have to interact with the Java ecosystem quite well, but you also want to start adding these things like checking for null value. Like how do you enforce in your type system that you'll never access a null value even if you're interacting with Java, which has null values all over the place. Or now you also look at like Rust, which is like this super exciting programming language that comes out, and it has linear types in it, or like this, or a more practical implementation of some of this stuff, and has
Let me
these
ask you
concepts of
something.
ownership. So,
does Rust have no pointer?
A null pointer.
Yeah.
I guess if you use unsafe Rust, maybe you could, and you have a pointer type, you could just cast 0 to it. But like, why would you ever use a null pointer when you have the option type?
That's my point. No, yeah, exactly. Because I'm thinking of how Tony Hoare came out saying that the null pointer was his worst mistake of his career, right? Like the $1 billion mistake.
Yeah, billion-dollar mistake. Yeah.
So I hope, yeah, it would be really nice if a big language that is taken over like Rust doesn't even allow having them nowadays. Like have really strong guarantees about your types like that, right?
I think this is something you can do in like in like the Kotlin and TypeScript types of languages, that where they interact with some underlying language like Java and JavaScript respectively, that can have these null values, but then you can overlay a type system on this, and so you can have checks for null values, and then so then at the type system level, you can like guarantee that after this point, after you did this check, this value will never have a null value, going forward. So I don't know. This is why like type systems are cool.
So moving forward with the survey that we had here, we have a few questions asking if they have familiarity with. Oh yeah, before that, there is a question on how relevant they think that cock is for their research. And we had an 8, and most of them are like 2, 3, and 4, right? So like for most of people, I feel like, well, for most of people that answered this survey, I feel like even though they enjoy the process of learning, it's not really useful directly for them, which for me in particular is kind of like a pointer that we still need better tooling for for the kind of work we want to do with all this programming language research, right? Like with guaranteeing safety of our code, guaranteeing the nice properties that we want to guarantee, right? And actually, it comes to a later question that are what are the things that you like about Coq? And we'll get there in a second. So, anyways, my point being that, well, I feel like these people that answered the survey here, they were happy learning Coq and thought it was a fun experience, and they could learn some interesting stuff from it, even though it's not directly relevant and applicable for their research, really. And most of them, we have people here from that does systems, that does machine learning, that does databases. Again, it's not that many people, but it's a. Well, yeah. One thing that we also forgot to mention is that this is kind of a required course, right?
For master
So
students. Yeah.
right. Yeah. Master students, they get to choose between compilers and programming languages. So in this semester in particular, I think we had many more enrolled people than usual, because we had a lot of new masters incoming that didn't start their research during COVID. I think they kind of postponed their acceptance after COVID. So there was this huge amount of new students that just came in, and they have to abide by these rules that they have to take either compilers or programming languages, and programming languages was being compilers was also offered this semester, right? If I remember
Mm,
correctly. No?
I'm not sure.
Yeah, yeah. Angelo was a TA for compilers this semester. So yeah.
That was
No,
undergrad compilers.
it was undergrad compilers.
Oh. Anyways,
Yeah.
so programming languages was offered this semester, so the students decided to come here and pick it up. So it was unusually a large amount of people. I think it's usually like 40 people. That is, this course is usually designed to accommodate 40 people. So we were like almost twice as many people taking this course this semester, which was very
I
unusual.
mean, yeah, it's kind of a good thing though, because that means that there's a lot of new students who they have a reasonable degree of proficiency because they've made it to a master's. They're doing a master's, so they're strong
Right.
programmers, and we're introducing them to, in some cases, they're an entirely new paradigm of functional programming, and for everybody, I think is introduced to this idea of like, a formal proofs, which is super exciting.
I agree. I agree. Even though, well, I don't know. I think like at the same time we're kind of biased, right? We are biased here because we all are doing programming language research, and I believe that everyone that does research think that their area of research is the most important research in the world, right? All other research are dwarfed by the importance of this. Like, so people in our field will be like, yeah, computers are taking over the world, so and computers are run by programming languages, and so our field is obviously
Yeah.
the most important field there is, right? Because even machine learning will be using our tools. And I'm like, yeah, sure. Sure.
Yeah.
And so are the doctors that have to treat
Yeah.
cancer, and so are dentists that will make sure that we can eat properly. I just feel that I really don't like that this encapsulation of this or that is more important. But there is still a point being made that, I mean, I feel most of the students, it's not a feeling. I know this for a fact because I was looking at the numbers of the students that are admitted, and I've been talking with professors, and most of the students that apply for a PhD, they're going for machine learning. So most of the people, I want to actually look at the actual statistics, but I know that most of the people that start a PhD here at Purdue, they are starting for machine learning, right? So it's fair to assume that most of the people who are here taking this course was for machine learning, right? So even if they don't see the immediate value of what they're learning in this course, there are things here and there that can always be useful for whatever they're going to do, right? So they will have a stronger foundation to understand what is actually going on when we're talking about a compiler, when we're dealing with, as Patrick said at the beginning, when you're dealing with Python interpreter, right? So having this understanding, you know better what the error messages are going to mean or how to properly interact. And maybe even someday you need to come up with a patch for your example, right? For whatever program that you're using. So for example, I know that um, Lua is a very popular language for scripting, right? For providing the glue between different languages, right? So there are many subfields, many fields that use Lua a lot, and I know that Lua. I was watching this other podcast the other day. The creator of Lua is actually Brazilian. I don't know if you knew this, but he was like, they don't want to actually provide this canonical Lua like you have Python. In Python, you're supposed to be using 3 point many, 3.11, 3.9, whatever, but because 2.7 is already outdated, right? But for Lua, they do the opposite. They're like, hey guys, we're gonna keep doing improvements to Lua, and we don't care if we're gonna break things behind. So if you really need to use Lua out there in production, you have to stop, you have to fork our code and just maintain them yourselves, right? So whatever person that is going to be in charge of maintaining this Lua code, and sometimes they even have to add something to this Lua code base. Having a course such as compilers and programming languages and understanding how programming languages can be kept safe, right? And what are the guarantees that we need for that and how to reason about our programs is definitely going to be really useful, even though it has nothing to do with, say, scripting and whatever scope you're dealing with Lua, right? But then again, just because you're using Lua, then maybe you have to maintain a piece of the code of Lua, right? Or add a new feature to Lua. These are going to be really, really important knowledge to have in your mind. So yeah, that was my point. Moving forward in the survey, we have here a question about the things that people kind of liked about Conk. So do you wanna tell us what you liked about Cog, Patrick?
Sure. I mean, I think we kind of hashed it a little bit. Is that I like proving that my code is correct, and that like if you can lay out, it seems to me that like if I can lay out the semantics that I'm looking for, and I can like properly describe what my language looks like, and then I can go and actually formalize like, hey, what this is what a correct interpreter like looks like, and these are programs, and if I run these programs, they'll exhibit the behavior that I expect. So correctness is kind of king, you know.
Yeah.
Super.
I mean, I don't have many opinions about cockets. I mean,
You don't care enough
yeah,
about
yeah. I just use it, and I'm not sure whether I will use it ever in my life again. I don't know. I don't know. I might. I might.
I
Yeah.
mean, in some sense, though, that's like what most of these people who take this course are like,
Yeah.
right? Most people are
Yeah.
taking this
Yeah.
course like they're master students or PhD students doing other, doing system stuff like you, and they're like they take this course because it's kind of cool and they learn some cool stuff. And I guess like Ben and like the TAs like hope, hey, maybe they'll take some cool idea from this. Like maybe you'll get some new appreciation for like what do the semantics of a language look like, or like how do you reason about whether or not your thing is correct or that kind of stuff. But then you're going to go on and you're going to do your own stuff. And we just kind of, it's like when you take operating systems, people hope like, hey, maybe you'll have some new appreciation for how an operating systems work, and maybe in one niche case you might remember something that'll be helpful, but otherwise you're going to kind of go on your way. No.
Yeah, that is true, that is true. Yeah, it's good to be
So
aware of the existence of cog and being able to prove these kind of cool properties about programs. And yeah, I think it's
Supun is
not
actually a very good.
specific to
No, I feel like you're very good, like stereotypical student. This is
yep.
versus like
They're
I'll
really
represent.
average.
Right, because I'm not like the, I don't know, like the passionate PL guy. I'm just like
Right.
an average
Mm,
programmer kind
mm.
of a thing. So yeah, I guess for me, yeah, it's pretty cool that we can prove stuff about programs. But I guess at the same time, one thing I felt about the proofs that we did was, I mean, the world was kind of too perfect. Because
Right.
yeah, I mean, especially there are no things like side effects, and the programs we looked at are kind of simple. And one question I had, like one yeah, I was curious whether these kind of things scale to large, like real
Hmm.
world things. um and yeah, that's one thing I felt.
I think
And
Ben definitely did a really good job in kind of, you know, both Ben and Benjamin Pierce with Software Foundation, right? They do a really good job in protecting the students with the nasty details. So they're gonna be like, "Hey, these are the things that we want to do, and here's our code. Here's our setting. Here's this little piece of proof that I want you to make, and it's non-trivial, right? Like you really
right.
have to use the knowledge that you have acquired so far to hack things out, but at the same time, you're really protected. In really this protected little world, saying, well, you don't need to care about these nasty details around, right? Like for example, maps and context. You already had that for free, right? But when
Mhm.
you're actually
Right, right,
implementing all of that, there are so many questions for you to do about maps and the lambda abstraction and how to properly talk about your indexes and binding. Those are
right.
really hard questions, and these are
Exactly.
when you look on that from outside, they're so minute. They're such a minor implementation detail, but when you're actually sitting down and doing them, they're huge headaches. So then Ben and Benjamin Pierce on Software Foundation, they really do a good job to not allow you to be afraid of this huge pain points. I want to say, right? But I don't know. At the same time, having those pain points taken care for you so that you can actually focus on the important parts that we want to look at, right? It's good because it allows you to learn the tool in an interactive way, and you're still feeling like you're doing good progress and you're not spending too much time on details, right? And then later on, when you want to come back and actually maybe do a bigger project from scratch, you will be better equipped because now you have a much better understanding of how the system works, what to expect, what you should have in your head, in your mind, right? And then things will start getting more exciting. Let's put it that way.
And I
So,
guess we did get to
well,
see a little.
mhm.
We did get to see a little bit in terms of side effects because we covered featherweight Java, right? And that's where you start to interact with the heap, and you start to have like this other area where you start to where you have to start to like deal with memory accesses in like a very simple sense. No?
Eh, I think we had this discussion before, right?
Oh no,
I
maybe.
Yeah.
don't. Yeah. I don't really consider Federated Java to have a heap. That's not really a heap. It's different. But I think I get your point because you have to kind of like do some search and some graph traversal in a sense to find where your method is actually implemented, right? In this lattice of classes, right, something along those lines, right? Because you don't know where the method is, right? So you have to keep going down and find out, is this method here, is this method here, and you keep going down, right? But you don't really have a region in memory where you're putting the value of your list, for example, or your actual variable, so that you can reference that region outside of the scope of your method, for example, right, or outside the scope of your class, for example, right. If you want to access your variable, you have to have the you have to have a get inside of your class, right, and call that get, right. Still very functional in that sense.
I mean, didn't
He's
we have
lost.
dereferencing and stuff like this? Yeah, maybe. I got mixed up a
Yeah,
little
sure.
bit. And once you start talking about
Okay.
classes, then I was like, oh no, maybe I got
Yeah,
mixed
Well,
up.
that's
I think
Wasn't there
featherweight.
like
Yeah, featherweight was, I think, the most important part was, I think, reasoning about these classes and like
right.
hierarchy of classes and um, dynamic dispatch and stuff like that. So I think it does a good job at modeling that. I mean, I guess it models the real thing. I know, you know.
Right.
I think it does.
Right. I think for me, I don't know. I'm kind of chewing to the weeds now. And with Coq, I've been doing my PhD for 4 years, and maybe 4 year more before that. I've been using Coq already. So I want to say that I consider myself a somewhat advanced user of Coq at this point, right? But one thing that I like about Coq is that, so for example, I'm doing some research that I've been doing some translation in OCaml, right? And right now I'm trying to reason about the correctness of this translation. And I found myself, I'm not doing it in Coq. I'm doing all pen and paper because I thought Coq would be too burdensome with all those little details, right? So I don't need that level of reasoning, and I think it's going to slow me down. So I'm happy to do the pen and paper proof. That should be fine. But right now, I am in a point of my proof that I am trying to implement a very algorithmic part of this translation. And I felt like the pen and paper proof was just so tedious, it was so boring. All these cases and checking if variables are the same or not again and again and again, and induction. And I was so bored. And like, just going through the same sort of stuff over and over again. And I decided, oh, well, why don't I do this in Coq and things should be much faster, right? So I started doing it, and in 2 days now, things were so faster, like so much more fast, because now I can use LTEX to get rid of all the boring details for me. And the final theorems that I'm interested in, they're still there, and I can see if the high level details are solid. And this minor, I didn't actually implement the full thing. There are some cases in my language that is a little much more complicated than necessary, so I'm not actually doing that. So but I can still reason about all of the other boring cases just to make sure that the stuff that I intuitively think should hold actually holds, right? And I'm not actually missing any of the boring corner cases, right? Because Coq is going to be really annoying to make sure that those corner cases are taken care of. So that's one thing that I think is exciting, not only for Coq, for any tier improving. It just happens that Coq is the one that I have the most familiarity with, right? Anyways, there were some other opinions here as well for what people think that they liked Cog. There was one here that really drew my attention because it's been a while that I don't mess with that I don't actually like install Cog from scratch or use that Cog company that is a big thing nowadays. But I've heard some good things about that, but I didn't know how good it actually is. And there was one student saying that he actually really enjoyed the tooling for Cog. The tooling for Cog is really good in my opinion. I rarely had any trouble with the IDE and etc. And it was always worked as expected. Now, I think this guy is I don't know. I don't think Cock never works or expected for me. So this guy he was doing some stuff really right. He's good, man. He's good. I'm proud. I'm proud. This is our student, man. So there's another answer here saying that he really enjoyed the challenge. Problems are presented as logical puzzles for to fiddle with, which is exactly what Patrick was talking about. And well, and the no more sub goals message is incredibly satisfying. Yeah, that's the mode. That's definitely the mode. This is what we call video game theorem proving, right? You're just trying to play the video game and just applying the tactic that actually fits here, right? It's just a challenge to do that. There is another answer saying that the tactics are clear and the goals are distinguished properly. Nice. Yeah, yeah. That's what I was saying. It kind of like helps you to think about the cases of your proof as well, because sometimes you're doing an induction and it raises this question, right? Like when you're doing induction in pen and paper, it raises this question of, wait, what is my induction hypothesis again? What do I get for free here? How does things relate to each other, right? Like, can I actually apply this theorem, or is it anything failing or missing here? But with Coq, with an interactive theorem prover, no, you don't need that. It's kind of like he's guiding you through this process. He will give you the induction hypothesis for you, and will make sure that you're just applying things that are supposed to be applied at this point. So that can also feel really nice if things are going in a nice way. And he also said that tactics are clear, and we didn't actually teach that much LTech in this course, right? Because one because once you start learning how to actually come up with your own tactics, then you can actually come up with even more clear proofs, right? Because then you don't need to be naming your variables all the time and your hypotheses. You can just do this huge proof of this huge. You can do a huge manipulation of your proof just by applying this one tactic, and like inversion and then substitutions and rewritings, all in this one tactic that will encapsulate much of the tedious parts of the proof in whatever context you're doing, right? That's kind of the idea presented in CPDT from Adam Shipala. And it's a really good idea, honestly. It's a really good way to think about your proof engineering here at this point. But again, in this course, we didn't go that far. Just something that I wanted to share. And the last guy here, he also talks about type inference, which was surprising for me, but it's actually a really good thing, because I was actually making this comment to Patrick the other day, because he didn't know that ML. So ML was well, maybe I'm saying something that is not quite right, but the best of my understanding, ML is the first language that had type inference done really well, right? Like with Robin Milner type inference. So you don't actually, even though your system is strongly typed, you don't actually have to go through all of these tedious details of how all your, or what are all the types that you're actually mentioning here and there, right? If you ever use Haskell and OCaml, you know this. It doesn't, just because you're defining a function that doesn't have a type signature, does not mean that your function is not strongly typed. Your function is still strongly typed. It's just been inferred for you. The compiler is doing that work for you to figure out what is the type that is going on here. That's type inference, and it's really strong and it's really beautiful. And again, to the best of my understanding, the first language that actually implemented this strong notion of type inference was ML, just ML, not SML, just ML. And ML was created for was and ML is a language that was designed in order to create a theorem prover called LCF back then. It was done in Edinburgh. I don't know which year, because I suck with the years. But my main point is that type inference, in a way, was kind of created for a language to do theorem proving, interactive theorem proving, which is really, really exciting. Okay. Next question. What are the things that you dislike about Cog?
Dun, dun, dun.
What I dislike about Coq. Well, I mean, it's not a problem with Coq, but I think it's the nature of the problems we deal in Coq. Sometimes you get stuck in proofs, and I don't know, like you get stuck and you cannot proceed, right? So, I mean, it would have been nice if the language can, I mean, I don't know if the language has any, I don't know, hints or anything, some mechanism to help you.
To give you more
um,
hints and to give
so,
you more
right,
feedback on
right,
like
right. Yeah, yeah, yeah.
these are approaches that you could try here at this point, or like
Exactly.
maybe
Yep, yep,
invoking
yep.
some machine learning techniques to try to prove things for you, right? And
Right,
actually,
right.
maybe you don't know this, but this other theorem prover, Isabel, they have this tool called Sledgehammer that calls a bunch of SMT solvers on the back just to try to literally sledgehammer your proof for you. Bah! It's done.
Yeah.
So that doing something with that in Coq would be really useful. And actually, there is a
Yeah.
tool in Coq called Cockhammer. Uh, I don't know much of the details about what that tool actually does, but I heard at some point that it's not really the same as Sledgehammer, which is expected because the underlying theorem of Isabel is kind of like higher order logic, and here in Coq is kind of like the lambda calculus. So there is this kind of mismatch going on there. It's kind of like simpler to translate things to an SMT solver in Isabel, I believe. Might be wrong, but
Mhm.
seems about right. Patrick?
Yeah. What else?
Yeah, I think like when we talk about like what do we dislike about Coq, it's kind of weird because we're all like new students, so we have very like surface level things that we dislike about the
Mm-hmm.
programming language, or about like our experience with it. Like actually, I guess I was just kind of remembering since we were talking about like how the tooling was so good. We had that comment about how the tooling was so good for Coq, right? Like, but I remember like my two gripes that I always had with the Coq tooling was one, you couldn't do any syntax formatting for this. Apparently, there's like this Coq thing called Beautify, like
Does
Coq
that
C
work?
dash Beautify.
You
It
could do
actually
that
breaks
with
your
version.
code. No,
What?
it like you read it, it breaks. It's like with these, it like formats and beautifies your code, and you can't run it
But it doesn't
anymore.
work anymore.
So that's the thing.
Wow.
So what you're saying is that Coq code cannot be beautiful, otherwise it won't compile.
Yes. No, but VS Code had some sort of formatting, right? If you type, I don't know, like QED, it aligns with proof and stuff like that. I think VS Code had some, at
Has
least
some
auto
auto
indentation.
has a little bit of
Indentation at
auto
least.
completion. Yeah. Though I guess
Right.
VS Code also has this thing where like if you have a period, sometimes like I would like try and like enter to go to the next line or something like this, and it would mistakenly think that I'm trying to autocomplete the period thing. And
Oh, I hate when
they
that
would like put in some
happens.
random thing.
Right,
Ah.
right,
They
right.
put in some like completely random like word there that I don't understand where it's
Right,
coming
right,
from. And
right,
then
right. Yeah, yeah,
Dude,
that
that's
happened.
always the first thing that I disable in any IDE is autocomplete. Dude, that's my personal hell. I hate when I just type in there and then I was like, there's this random piece of code line
Oh,
there.
wait, you
Ah,
mean
no.
like for
Go away.
any language you don't like auto
Yeah.
completion?
oh.
No, yeah, it's true
Hmm.
autocomplete. And
Oh.
let me do my own errors, okay? I don't need the tool to make my errors for me.
I don't know. I
Yeah,
mean,
I
for a language like Java or something, or building, I don't know, like a system,
No,
I would,
no,
I would
no. Okay,
like
fine, fine.
having
I
But
think
then
automatically.
I would prefer. I usually prefer if there is a key binding to activate when I want to search for the autocomplete. Right. For example, control space, and then it shows the bar where I can choose. Okay, these are the things that I can
Hmm.
autocomplete. Now I'm gonna pick this one in particular. Right. Don't just go ahead and try to autocomplete things while I'm typing here, and then I just press enter because I want to go to the next line. Oh no, that's not what I'm trying to do. Right.
Right, 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 right.
Yeah.
Yeah, I think I've had good experiences with like auto completion from IDEs, especially where you're in languages with a lot of boilerplate. Or
Yeah.
like I know the thing that I always use it for is in Rust when you're implementing a trait. There's usually you have some function signature or a set of functions that you have to implement for some trait, and it can go and you can just it'll automatically just give you the skeletons of all these different
Yeah,
functions, and you can
yeah,
just
Oh,
and then
cool.
now it takes care of all the little like syntax stuff that you have to worry about, and you
Right.
can just go ahead and like fill in the body of the statements and stuff like this.
yeah.
That's
Versus like
nice.
for some reason in Coq, like or at least in the VS Coq extension, like autocomplete just it doesn't work the way I expect it to. So it always throws me off whenever it's trying to do something. So I don't know. It just but then again, I'm super spoiled with I feel like Rust has a very like very good tooling story. And
Yeah.
like they put a lot of effort into like the program experience. So like
Yeah.
everything compared to that seems a little lackluster.
To be completely honest, I think this tooling has improved dramatically from when I first started working with Coq, because we didn't have VS Code. I remember the Vim plugin to actually work with Coq was completely broken. If I remember correctly, it's back. We have a new Vim plugin now. So if you wanted to use Coq, you would either use Coq IDE, which was really hard to use on a larger setting. Like if you have a larger code base, things would break really fast, because then like have to make your code, and then the Coq that is being used by your console might not be the same that your IDE is using. And I saw that some students still also had that problem this semester. But things has improved dramatically in my point of view, because I don't know, like Cog doesn't get that much money to implement tooling either, right? Like this small research. How do I call INRIA? INRIA is this research facility. Let's put it that way in France, right? And it's basically some researchers doing this work, right? So yeah, it's really nice if we get more tooling, good tooling for Cog. There's some, there are a few really good people working on this. I remember when we were at Uppsala. If you remember Clement Pital, he was doing some tooling work for Electrion. So in order to show your proofs in the website and follow along, and also printing stuff. I don't remember all the details, but it's some really really amazing work. And I remember he's saying like people here doing this sort of work and Coq, we are very resilient to bad tooling. That's his, that's his strong opinion about it, and I agree. I agree. We there's still a lot to be done to have good tooling for Coq and other interactive theory improvers as well. Okay. Um, let's see here what other comments we have here. There's a guy that he's really snarky about notations. Notations. I never properly understood the notation mechanism because the Coq compilers always complain when I try to do something new. This was not an issue for the homeworks because they were set up properly and we didn't have to tinker with notations. So again, this is a good point about how Ben and Benjamin Pierce, how instructors do a good job in sheltering the students and providing this really good environment that makes sure that things does not break. But I wanna stop at this comment for a second, notations, because I think notation is both it's both an amazing feature of Cog and a really devastating feature at the same time. Why? Think about it for a second. What the notation in Cog is doing is effectively changing your language, changing the actual syntax, the actual grammar of your language at runtime. What other programming language does that? I've really never seen any other programming language that's doing that before. If the listeners know any other language that actually does this, you change the syntax of your program, the grammar of your program at runtime. And in a sense, this is not what macro does, right? Macro is just expanding and extending things. I think maybe C++ has a somewhat similar notion in defining operators, but still, Coq gives you the full power of going down at your syntax and change anything you want. If you want to break pattern matching by changing that syntax with notations, you can. I've done that before, and it's hell. It's hell. Things can go really wrong when you use notations, so you have to be really careful. But at the same time, if you use them well enough, like if you behave yourself, which is kind of what I believe the fathers of Coq was doing, is like he's trusting that everyone here are adults and know what they're doing and are not going to break things catastrophically. Notations can be really really helpful because it will provide you this nice little grammar for you to talk about whatever you're talking about, right? Like to actually reason about your tools, right? You can actually come out instead of showing this big syntax, you can actually shorten things up and use mathematical notation, and then you can provide precedents to show how this notation work, and you don't need to use parentheses and all of that. So it cleans up a lot when you're doing your stuff, and then it's a lot cleaner and easier for you to look at your code and know what you're doing. But on the other hand, what it what may happen is that every time that you migrate from one Coq project to another Coq project, say you're changing labs or you're working with other people or you want to contribute on this open source Coq code, you will have this hump time that you have to learn all the notations that you're using. So effectively, what may happen is that you have to learn another language just to start contributing in this other project, right? And that's not really great. That's not really great. But as I said, if using parsimoniously, things can work and things can work really well. But if they don't work, they can also not work really badly. So those are my 2 cents about notations. They're great and awful at the same time, but they're really great but awful. Did you guys do anything with notations or just use whatever was there?
Yeah, I just use whatever that is there.
But it makes sense what I'm saying, right?
Yeah, yeah.
Yeah, I feel with it. I agree that um, like notations, especially from like the new student perspective, is like the best and also like the most confusing thing about Coq. It's the best thing in the sense that whenever we would write out like our little type inference rules or any of any of our formalisms, a lot of time you could almost copy and paste the formalism, and you can now make that part of your whatever the statement you're trying to prove, or you could write it as part of one of your cases. And then on the other hand, though, it's like also it also seems very confusing. Like there's these things like notation levels. Like what does a level 40 notation level actually mean when you're doing this kind of stuff? Or
Yeah.
I think what's even worse actually is when you have notations that are not a single symbol, but they're like a set of symbols. So it's like you might have some like outward brackets, and then you have like some parts in the middle. Because what makes that difficult is now it's hard to search. If you have a single piece of syntax, like just like a plus operator, you can search for this thing, and that's very straightforward because it's just one symbol. But when you have like a full like array of symbols that are count as like one piece of syntax that you're supposed to match on, it actually is like non-trivial just to like craft whatever your search
Right.
match your I don't know
Yeah.
your search pattern for
Search pattern.
your search pattern for that syntax, and that can get kind of frustrating because you're like, I thought I could just match on this little piece of it, but I actually need to use this combination of brackets and underscores and try and get it just right. And so you actually, in some sense, when you're looking at syntax, you're not sure, is this like one is this symbol for one operator, or is it like multiple symbols together form one operator, or like what exactly is going on here? And then I guess you have to kind of
Yeah.
look up, and eventually
Yeah.
hopefully you find a Stack Overflow post that tells you about you can unset all of you can do like an unset all notation. Was that, I don't
True.
know, print
Yeah,
on
yeah, that's definitely a
store?
thing. You can unset all your notations. Yeah. I wish there would be a simple way for you to, click on a symbol and it will tell you what is the notation, like what and where does it come from, right? Like which file is it at and how can I go there and see exactly what this notation is doing, right? I like to see it like that.
And I think another thing was errors. Like if we have fancy notations and stuff, and if
Oh yeah.
we encounter some error,
Yeah.
it's the error message is not clear at all, right?
Yeah.
Because
I
yeah, it
think
says some type error does not
yeah.
match this and
Yeah.
that, but it's
Yeah.
really hard to like find what is going wrong
Yeah.
sometimes. Yeah.
That's actually another complaint that I have here in the survey is that when error happens, it is difficult to identify the trace. And I definitely agree with you. It's really hard to debug Coq code. I think in general that this is my personal point of view. It's in general it's hard to debug functional code, right? Functional programming code in general because there is no actual stack trace. It's just one huge, like function. You can say that way, like just a function. Like maybe you can see what function called what, but there is no, like step by step of what is being done, and you cannot. It's hard for you to kind of like step through the execution of your code, right? Because there's not really a step through in a sense, right? Just a
So I guess like
computation
you're saying like
happening.
when you chain like if you have an iterator and you're chaining like multiple maps and folds like a lot of these things together, it's kind of hard to debug what's going wrong because
Yeah,
it all kind
yeah,
of happens together.
yeah, yeah,
I could see that.
yeah,
I was gonna say in general, like lazy computations are harder to debug because I mean it. I mean, if you have some imperative code, you can basically step through the code and you know what's going on. But on the other hand, if your computation is kind of lazy in the sense that I don't know, like if you have a map, it does not actually perform a map. It only creates like a representation of the map operation, and then I don't know. Once you like want the actual result, then you would actually do like the computation, right?
yeah.
Yeah, in general, I think it's that might be relatively harder to debug. I don't know because yeah, compared to imperative code, but I might be wrong.
Yeah, yeah, it can be kind of. There are ways to introduce trace in, say, Haskell programs. There is good library for that, but in Coq, that's really hard. And also, you're not only debugging not only your code, but then sometimes you have to debug your inductive data types, right? And you don't run your inductive data types, you're going to see it much later that, oh, this definition here is not allowing me to go through this particular case of this particular proof that I'm doing here, and I have to go back and rethink what my inductive data types actually should be doing, right? So it requires a lot more reasoning up front, right? It requires you to sit down and look at your code up front and reason if things make sense, right? Whereas in imperative code, you can, like do unit testing and try this, try that, and see if it works as you expected, right?
Yeah, I guess that's the thing with
But
inductive data types that you
hmm?
only figure out that your inductive data type is wrong when you're in your proof and you're at the very and you're like all the way down. You've gone down some branch of your proof, and you've reached a point and it's impossible for you to prove. And like
Yeah.
after
right,
you've banged your head against this thing, you're like, this is actually impossible to prove.
yeah,
And then you're like,
Yeah.
okay, I messed up somewhere in my inductive data type. I need
Right.
to
yeah,
back up and redefine it or something like
yeah,
this.
yeah. This reminds me, I was doing a proof today that I was doing this proof. I was really down deep in the woods, and then much later on, I'm like in the middle of a proof. I'm like, and then I get to this impossible case. I'm like, what is going on here? Why is this E1 and not E2? Where does E1 come from? This makes no sense. What went wrong? Oh my god, there's something wrong in the lemma that I'm trying to prove. What went wrong, right? And then I step back two cases, and then the error came from the definition of my function. I'm like, what? So I had to go back to the function and change E1 to E2 exactly as you're saying, right? Because it just didn't make sense, but I could catch it very early on. It was easy for me. So I was lucky, I think. But yeah, it happens. So yeah, trace and debugging and error is hard. I would in general I would tend to agree with that. And finally, another complaint that we have here, or at least another another thing that he disliked was LTAC. Another thing is LTAC and any other related proof automation tactical. While the given tacticals worked for the homework, I'm still not sure if I'm confident of writing LTAC tacticals myself. For instance, in the last few homeworks, I knew that some parts of the proof can be automated because most of the subcases followed a similar pattern, but never bothered to write LTAC and instead copy and pasted the tactics myself. I think this is a general approach when you're programming, right? Like if you're in this small little case over here and it doesn't cost you too much to do a copy and paste, you go ahead and do the copy and paste. That's no big deal, right? But then later, when you see that you're doing your copy and paste again and again and again and again and again and again, maybe you should make a function for that. Or in this particular case, maybe you should do an LTAC for that, right? Like abstract away the tedious details and pull that off, right? So another thing that I was commenting to to Patrick offline was that I understand that when you're first learning Cog, looking at the syntax for writing LTAC can be a little, horrifying, because all those question marks and brackets and errors and match goal. What is going on here? But then I remember feeling like that when I was first learning, right? Like I was scared of LTACs. What is going on here? I have no idea. Like, it's just this huge amount of information that is just doing magic, right? But once you actually sit down and you put in your head, okay, I'm gonna sit down to learn LTAC. I swear, it's so much easier than it looks like. You sit down for a couple of hours and things are really straightforward. You already know what pattern match is, right? You just have to apply this knowledge of pattern matching to the context of your proof here in Coq, right? And once you do that, you start realizing all the amazing magic that you can do to actually manipulate your goal without ever having to name anything. You don't have to talk about, like have x equals y. You don't actually have to do like destruct eqb xy, right? Because that's how you do the the checks if you're if x is actually equal to y, right? Like if you're in an if branch, for example. So an LTAC can do all of that for you with a very simple, small, and elegant piece of Word, right? So it can help a lot, like a lot. And it's really nice. And it's much easier to learn than you would expect. So if you use Coq and you didn't learn LTAC yet, I would suggest that you take a look at it. It's a really low effort sort of knowledge that you can gain that will buy you a lot and save you a lot of time. I guarantee you. So
It sounds like there's a lot of parallels between, maybe almost intentionally by the name, between LTAC and LaTeX, writing LaTeX, like LaTeX reports and whatnot. If you think about it, because LaTeX is
good
just one of these things that
question.
it's always super. It's super scary to look at, and before you've actually ever written any LaTeX, it's very strange and like makes no sense. It's also
True.
super powerful when you're actually able to write it, because then you can write documents and stuff like this, and you have an incredible amount of control over whatever you're writing. The error messages suck because it's all macros and all this kind of stuff. There's no
Oh yeah,
traces on
like
anything that you're doing, and
yeah.
you can't examine anything, and you're doing all this weird syntax manipulation. So you kind of
Right.
hope that anything works out well. So I think we could learn. There's a lot of parallels here.
You raise a really good question, actually. Why is it called LTAG? You've got really good points, but I don't know. All your points are in the bad side.
Yeah.
No, there was the thing. It's both. I think in both cases, once you actually sit yourself down to actually like learn yourself some LaTeX or some LTAC, then you'll actually realize, oh, this thing is super. It's super painful, but
Yeah.
it's super powerful to use, right? So
Yeah. Yeah.
it's like life. It's like a life changing thing that you learn.
I agree. Nowadays, one of my personal hells, as you'll notice, I have many personal hells. Like, but one of them is when I have to use Word to interact with people outside academia, right? A Word document or a doc, right? It's just so painful. It's so painful. Like LTAC is just everything just so clean, and like I can do my own macros and use Vim, and then I don't have Vim, and then all of a sudden I'm trying to in Word I'm trying to type the word to be a particular size, and then I do enter, and I want to go back to the original size, but I'm stuck in this environment with this huge word. No, I wanted to go back to the original size. What I do, and then yeah, it can be painful because I have to use my mouse a lot, and I hate that too. I think other Vimers can also relate to that. So, does Word Online have a Vim plugin? That would be fun. Anyways, we went on a really big tangent there.
You're not gonna cover the most fiery take of all in terms of the things we dislike about cock.
Dislike?
Oh, the name.
Yeah, the name. That's the do you have any hot
Yeah.
takes, Pedro?
That is literally the next thing that I had here. What's the hardest thing? What do you think is the hardest thing about learning cock? Is that the one? No, that's not the one. Anyways, that would be another topic that I would bring up. Yes, and you are definitely right. And I think we have to change the name as soon as possible, right? Like there's stuff happening under the hood. Like there is a lot of community mobilizing, and the developers, they're actually really open to changing the name. So things are happening, things are in the move. I don't know if they chose the new name yet, but I have in the last cock meeting that I participated, I was under the impression that this is something that is happening. It's just a matter of time, right? And I understand it makes sense to take a little while, right? Because there is a lot of tooling happening under the hood, right? Like there's a lot of code written with this other stuff, like there's cock platform, there's a whole rebranding happening as well. So it makes sense to take time. But yes, I agree with what Patrick is saying. um I don't know, to be completely honest, I feel like cock no, to give a little bit of background, I don't know if you guys know this. I don't know if the listener knows this, but it makes sense. In a way, it makes sense why cock's called cock for a couple of reasons. Like there's a couple of things that make it a good name choice. The first one is that cock means rooster in French, right? So in French, there is no harm in that word. The second one is that the name of the creator of the calculus behind cock. Oh, yeah. The calculus behind cock is named Calculus of Constructors. Sorry. The name behind cock is named Calculus of Constructions, COC. And the name of the creator of the Calculus of Constructions is Thierry Coquin. So you take those three facts together. You're choosing the name COQ makes a lot of sense. It's a nice play of words, right? But at the same time, I feel kind of like this is kind of a joke that the sorry Coca, sorry for anyone who was making this language early on. It might not have been your intention, but sometimes I have this feeling, like using this tool nowadays, that the name cock is also kind of a joke with English speakers, right? Like you're there and you say cock in French, and there is no harm, but when a English speaker is gonna say it's really funny, right? But that's the thing. Now cock is it's a really prevalent tool in our field, and it's kind of un, un, unprofessional, right? Like there are some days that I'm in a coffee shop and then we're talking about cock and I speak it a little too loud because I have that tendency to speak a little too loud, and all of a sudden there's these weird people giving us weird look like, what? Why are these guys talking about porn? The middle of a coffee shop, these guys are weird. And I remember there was a tweet as well from Talia Ringer that she was, like talking about her research in an Uber. And then the moment she mentions that she does research with cock, the guy completely changes the way she's treating her, like starts kind of like sexualizing and making assumptions about her. And my point is that the current name is not very welcoming for females in our community, which are not many at the current point. So just to finish this point is that it's more than time for us to change the name of this tool. What else do we have here? What do you think is the hardest thing about learning Coq? I think it's adapting to the new setting. I had some prior experience in functional programming, so that part was not difficult. Even though I had experience with pen and paper proofs, I felt like some Coq proofs are just totally different than pen and paper. And sometimes I was able to come up with a proof sketch in pen and paper to prove some things, but it was really hard to translate that to Coq. And I get it. I get it. It's very different. Like you're trying to teach the program how to do the proof, right? So the coq it's very opinionated on how this proof is gonna work, right? Like you have to use the calculus of inductive constructions. I always say constructors. you have to use the calculus of inductive constructions, and it's really different from what you're doing in pen and paper, right? Like it's a lot more. You really need to provide a lot more details, so it's expected. It makes sense. So yeah, that's kind of hard, but it takes after some time you learn to think in the same way that Coq expects you to think in a way, right? Mm.
Yeah, I think this is what a lot of people end up getting frustrated with is that like they sit at this thing and they're like, I know this is true. I know like I could prove it. Like if I was doing this in pen and paper and and when you're doing a pen and paper, you can kind of like gloss over some stuff and skip some steps and stuff like this. It's like I know I can prove this. But then you're sitting down actually trying to get the IDE to or get get your code to be accepted. And it's like for some reason you just can't convince Coq to accept your code. And sometimes it might be something super simple, like even at like the very beginning, like how it's always like so annoying that like it doesn't deal with like the some natural number times one. It's like just accept that natural number times
Yeah.
one is just the natural number, right? But instead you have to go and you have to do some whole rewrites and you have to like, and that's like something after, at the end of the course, I'm like, okay, I know I can do this like almost without thinking. But like when you're starting out, like those things are just like are some of the most annoying things because they're the most
Yeah,
obvious
yeah.
and they're also the things that Cock is like the most of a stickler for, you know?
True. But I think this example you gave, a common strategy to get past that is kind of like just assert what you want by Leah, because Leah is really good on solving these equalities for you. Like ring equalities, that sort of stuff. So you assert whatever you want, you do the rewrite, and you're good to go, right? Because Leah should be able to accomplish that really easily. So
Yeah,
that's a hint for
but in
you.
the
Sure.
beginning of the course, we wasn't
Yeah,
aware.
yeah, for
Neither we
sure.
were allowed allowed to use
That's
Leah, I guess.
that's another thing that I think that when I was learning Coq, I was kind of annoyed as well, is because since the community, since it's still really small community. So nowadays we have a formal proofs overflow, right? Stack Overflow. I forgot the name, but back then I would have to go to the IRC of Coq in order to get some feedback to learn these techniques, right? Like I'm stuck with this thing. Like what should I do? And I would have to hope that someone well intended would come and help me. And they helped me a lot, don't get me wrong, but I didn't have anyone that was teaching and could help me on these trivialities, right? Because this is just a matter of having more experience. So it's really nice that you guys are in a position where you can get this, like these insights firsthand and really, really easily. So like you save a lot of time learning this stuff, right? And I'm sure that a lot of the listeners, actually, I've been getting some messages saying, "Hey, I'm a software developer in this place. Like, I don't have anyone to talk about this stuff, so I'm really happy to be listening to your show." So I think it's many listeners will agree with this, like solitudes in a way, right? Because it's just such a small community, and we that are inside this community, we don't realize how small it is because we are inside the community, right? Like we have peers, we have friends, we have our advisors that all speak the same language, and we all know, like programming languages and Coq and this stuff, but it's not the average. It's not how everyone perceives, right? And it's one of the reasons I came to do my PhD in the US, actually, because in Brazil there are no people working with Coq. I looked it up. I think there was like one professor. Maybe nowadays things has changed. So if you're in Brazil and you're doing PL and in particular using Coq, send me an email. I want to talk to you. Oh
I
yeah,
wonder.
yeah.
I was just gonna ask, like, do you think there's like a? It seems like Cock has like this weird bifurcation where like you're either like a complete newbie who's like you're learning Cock for the first time, you're doing software foundations, or you're like this super experienced Cock researcher, and like it seems like there's very few people in the middle. Is that an accurate assessment or no? Do you think?
That's pretty much how I feel. Yeah,
But isn't it true for any language though? Mm,
I think
maybe
that's
not.
kind
I
of
don't
like PhD students, right? Like me. I would consider I'm in the middle. I'm not as nearly as a cock hacker god like Chipalo or Ben. Even Ben, God, he's so good doing stuff. Like sometimes stuck with something and he's like, yeah, just apply this like that and do this function here with this LTAC, blah. his work, right? Jesus.
Yeah.
So there is another big point that I think out of, yeah, there are a lot of opinions on this one. What is the hardest thing to about learning talk, right? And we have some pointers here about documentations. Do you want to say something about this, Patrick?
Sure. I the sense I've gotten is that in the documentation, it's if you're stuck on something when you're doing your cock proofs, or you're trying to figure something out, like you're pretty much kind of stuck with like some kind of textbook, like Software Foundations, or one of the other one of these other like teaching textbooks. Like, you can kind of go to Stack Overflow like a little bit, but especially as a new like person to cock, a lot, especially like the formal, the official documentation is not very approachable. You're not going to have much luck trying to like
Yeah.
look through some of this stuff. And I think that's kind of something that I've talked to you, Pedro, about, is like, even stuff that seems simple, you start to look at the documentation, and like, unless you have a lot of background knowledge, you're going to get really lost. And as far as I know, I don't think I've met a single person in the class who's been able to use like the official documentation for anything. So like, everything you kind of learn is like textbook.
I think I used the documentation for referencing syntax sometimes, because so there was this case, I don't remember specifically what it was, but uh, let's say there was a boolean, right? And I wanted to like distract and do like a case by case proof. And when I do a distract, then I don't see the uh, I don't know, the boolean equals true in
Oh, yeah.
the context.
You haven't remembered the. This is like where we have to add the
Exactly, exactly.
EQN colon.
Ah,
Yeah, yeah,
right,
yeah.
right, right. I wasn't aware of that, or I forgot that, and then I was like, okay, this is. I mean, this shouldn't be the case, right? It should be in the proof
Mhm.
context. And then I looked at the documentation and I saw EQN, and then I realized, okay, I should put this part. So, I mean, that was kind of helpful. But again, if you are stuck in a proof, then I don't think documentation helps you at all, right? Because it's, I mean, if you don't know the tactic to use, then I don't know how you would use documentation, I
Yeah.
guess.
I've always been bad reading documentations, especially because when I first started learning how to program, English is not my first language, so it was hard for me to go to the documentation because it's this really technical language and it's not my first language, so I would get completely lost. Doesn't matter what documentation it was. So I think like as I've been, maturing as a software developer, let's put it that way, I've always tried to avoid a little bit documentation. But taking on Patrick's point that he didn't know any students that use documentation, I myself, I think it's hard to like, we were before we started the episode, we were talking about this and he was making a point. I'm like, wait, no, but auto is easy to look in the documentation. It's everything you look in auto, and then we open auto, and then he's like, yeah, okay, so what's this thing here? And I'm like, and then we start clicking on things around, and I'm really confused as well. And I'm like, yeah, okay, you've got a good point. Even the most trivial tactic that you would expect, like auto, right? Like there is still some really serious technicalities going on in the documentation. And then Patrick, you were also saying how you would expect, more code examples and what are the use cases for each one of the stuff in there. So I agree.
Yeah, I think there's like, I think you kind of need something in the, like, in the middle. Like, I'm sure the documentation works really well for like, if you need like like the full, like, very technical, a lot of technical depth to what is actually going on with this tactic. Like, the official documentation, I'm sure, works really well. And if you have like absolutely no clue, I think the textbook does a very good job of like kind of, slowly introducing these things to you. But if you're in the, I think like, if you want to be like in the middle of like, I kind of understand some of these tactics, but like, I'm looking, and I'm not quite sure. I'm not quite sure how to use them, or like, I know like there's this auto thing, and maybe I can also include other like tactics. I can use auto with other tactics or stuff. Like, you want to see like, you almost need like some like documentation. It's like, here's like the top like 50 tactics that you might want to use, and then for each one, just have like, here's 10 different ways you can use this one tactic, and just kind of have a ton of examples. Because I think, especially as like as a new programmer, and maybe somebody who doesn't have like all of the background that you might need to kind of read this stuff, but you have like a little bit, you really lean on example, like coding examples. And I think once you see like examples, like even if the example doesn't quite tell you what this isn't exactly what you're looking for, like, oh, that like, it kind of helps you along your way. Versus like right now, it seems like you're stuck with either the official documentation, which is seems it's very much for like an expert, or software and foundations, which is very much like it has to like explain everything to you, and it like slowly introduces this information, and of course software foundations is also it's more focused on like teaching you something, versus like, I'm sure, I wonder like if I was like or more of like a proof engineer, and but like I'm still kind of learning how to do this. Like I don't need to like get taught this. I just want to know the answer.
Right.
It's like, and
Yeah.
how quickly can I just find the answer that I'm looking for? And right now it's like, well, I don't know. Hopefully there's a Stack Overflow post that does what you're looking
Yeah.
for. Otherwise you're kind of stuck.
I feel that a lot of the knowledge is kind of folklore in a sense, like people just know this, but it's not written anywhere. So I also feel like we should definitely have more blog posts relating to Coq, like more Stack Overflow questions. What's the name of the new Stack Overflow? There is a Stack Overflow just for proofs, just for theorem provers now. I forgot the name, but yes, I agree. I definitely agree with all of that. As I was saying, like if you're not part of the community, it's really hard for you to find these answers. But the people who knows, it's kind of like really straightforward for them, but they never wrote anywhere because they don't think it's worth kind of like just sitting down to share this particular piece of knowledge, right? So there's also kind of like some proof best practices for dealing with your proofs and whatnot that nobody talks about, like, but there are particular ways, and like people have kind of like struggled with these questions many times. And it's a really good thing that, for example, Shipala wrote his book, because that's kind of like one of the ideas that he was trying to tackle, right? Like to share more of these knowledges that goes unsaid in his thoughts and what he's learned throughout the years, but it was not anywhere, right? Like it was not actually written anywhere. So that's really good. We it will be really nice if we start getting more of that. But in order to get that, we need a bigger community as well. So as we grow and as these ideas become more popular and prevalent, I have a good feeling that this will become more available, and we'll have more documentation and more blog posts and more questions and all of that. So okay, I think, is there anything else do you guys want to mention? Because I think I went through the most important part of the survey, and I think I covered most of the stuff that I would like to cover in this episode. Is there anything that you guys think we left out? I think we didn't really talk about avars, for example. Do you wanna give a word about
I still have
avars?
plenty
I
of
think
I
it's
have plenty of a list of all the stuff that I don't like about. I remember I started making a little bit of list of stuff. I was like, all this cool stuff that would have been better. I mean, there's like, what was it, like the short list of like different. We kind of talked about documentation. Um,
what else?
I think that like what. So I guess the quick summary of like some of the pain points I feel like is like I feel like evars. There's a lot of like really like weird things that go on with evars with like this unshelve. How you do like unshelving is kind of annoying. You have to do some like there's a lot of like very weird like parts that don't work very well. Like for example, like if you for evars if you don't give a user defined name, if you use a generated name, then you can't use. Sorry, with evars you normally you have a generated name. It's like a question mark m or something like this. Or you could have as the programmer specify that this is going to be the letter M is going to be the name for this. If you as a user give that letter M as the name, then you can reference it later on in your tactics. But if it's generated by Coq, if it's a generated name, then you cannot name it. And then you cannot use it, even though in your IDE it looks the exact same. There's like a whole bunch of like these little. I think there's a lot of like little things that get kind of annoying.
But the
Um,
thing is that if Cox
but,
generating, it could generate something else, right?
true, but like we already have this thing with intros, right? If you just do intros, then it generates a whole bunch of names for you, and you can use those names, and
True.
it's not a big deal. So like
True.
for some reason around evars, there's a lot of these like little things that don't like they're not composable with the
Yeah.
rest of how Coq is designed, and I think that
Yeah.
like also is shown in like the unshelf tactic that
Yeah.
you can't semicolon the unshelf tactic. Like, oh my god. Anyways,
So, well, no, hang on. We went through so many times throughout this semester because you were always
I'm
so
still annoyed with it.
frustrated. Yeah.
I'm still annoyed.
And I just want to situate the listeners that one thing that I've been telling Patrick over and over again is that my personal feeling about evars is that it's almost as if it's deprecated. It's not deprecated because it's really useful. It has its use, but you have to use it wisely. And what I mean by wisely is you use it when in general, you use it because, I mean, I'm sure that there are some power users that really know how to the ins and outs of how this stuff are implemented and what are the proper ways to instantiate things. And there's also other ways to instantiate that we didn't teach, and I personally don't know. But my understanding is that you should use eapply, rewrite, and these evar tactics when you're confident that later on the you're gonna match those variables along the way, right? Because those are not really conveying any critical information about the proof that you're trying to accomplish, right? And the way that the way that Patrick have been using it all along the semester was like, oh look, I have this goal here and this sub goal that I can really apply the z apply here, and I'll just do it, and then later on things should match. And then I would look at his proof, and then he's expecting that Cox is gonna do a proof search for him, and we'll be able to be smart on how to actually build this EVAR. And I'm like, dude, you're not, that's not what evars are like. This is not a good way to use evars because you're missing important piece of your proof when you're doing this application. So I would sit down with him and show him, look, it will be more interesting if before we do this apply, we actually massage our goal and our hypothesis a little bit more, so that when we use the apply, if we use the apply, they will not get lost. They know much better what are we expecting for the shape of this data here, right? And again, what he was doing is just like, yeah, so we apply everywhere. Just try to do the most automation as possible, and we write and repeat, we write, the apply, we rewrite, and the auto, right? Dude, no, that's not gonna work because you're trying what he was trying to do in a sense, like do a complete proof search on all the possible subtrees of his proof. Like, sure, it's doable, but you will need a lot more LTech and like automation in order to make that actually happen. That's my point.
Mhm. Yeah, I think
In
I
my defense,
always used apply or exist whenever I knew that
Right.
down the proof I would
Exist
automatically
is
figure
even
it
worse
out.
because the
Right,
existential is actually where the important piece of information of your proof is going to happen, right? But
right,
sometimes you know that this existential is trivial from the context
exactly.
that you have, but when you're doing a proof with existential, that's not usually what you're trying to accomplish, right?
Yeah,
You actually
yeah,
have that's exactly what you want to do. It's like tell what this existential is about, right? So yeah.
yeah, yeah. And apply was really useful in what's it called, horologic, because we
yeah,
sort of
Right.
know what kind of, yeah, because we once we know the condition, it's you can fill it
Yeah.
out like
Yeah.
one after the other, right? So
Sure, it was
yeah,
it was useful in horror logic, but it was when it shoots you in the foot the most as well, because you need now this is something that you actually cannot use the apply. It's when you're using for when you want to use in the
the
while,
loop
you have to
condition.
provide
yeah,
the
yeah, yeah, yeah,
loop
yeah.
invariant, right?
Right,
And the loop
right.
invariant is undecidable in general. Like providing a loop invariant is undecidable in general. So if you use the apply, you're actually trying to do a proof search in an undecidable problem. So this is obviously not gonna work, Patrick.
You have to know that the invariant you have to supply, and Coq wouldn't find it for you. I mean,
so
Patrick was expecting Coq to figure out the loop invariant for you.
I mean, that would be nice. Coq can solve my homework for me.
Well, since you're at it, just solve the halting problem along the way. Why not?
Right? Yeah. Just use the apply and it'll.
I feel like that's one of the first things people do is when they learn about e-constructors. Like, the very first thing I'm gonna try is just do repeat e-constructor and see what happens.
Yeah.
And you know what sometimes happens though is that it runs forever and Coq doesn't time out. So it's actually just like it actually could lock up your entire IDE and you have to restart.
Yeah. Well, but there's usually a command that you can stop the IDE, like stop the proof engine. So in Emacs, it's like Control-CX, something like that. So you have to learn that before you do e-constructor.
Because once that happened to me, and my IDE got stuck, and my entire machine got stuck. So I couldn't even Google. I knew there is like a command that I can use to like stop the thing, but I couldn't Google it. So.
Dude, that has happened to me in the past as well.
I feel like that's almost like a rite of passage. Like once you learn about repeat and once you've learned about e-constructor, like the very first thing every new student almost thinks is like, what if I put these two things together? All my proofs will be solved.
I'll solve all the problems, right? Forever. Oh man. You're gonna defend yourself somehow. What are you gonna say?
Yeah.
No, I think my defense is those two things. First, that it's used like despite you saying that it's deprecated. I don't think there's anything else that's come to replace it, right? And like it's also just prolifically used for like doing Hoare logic and doing a lot of this other stuff. So I don't know.
That's the thing. Like, so it's not that really deprecated. Like it's not, but like. Well, I cannot say in the name of the Coq developers because I don't know what they're doing, but it's kind of clear to me that it hasn't received as much love as other parts of Coq, right? And the reason is because there is a particular way that this is expected to work because it's really useful, but it's really dangerous as well. So yes, they could develop better tooling, like better support and better way to make sure you're going to use it the proper way. But, well, there are other things that are kind of more important. And this is not super, super important, right? Like this is just, if you use it, if you're really strict and, like using it in this particular way that I'm mentioning, then it will help you a lot to save time. And at the same time, they're not going to bite you in the foot. Well, not bite you in the way. At the same time, it's not gonna shoot you in the foot.
Yes.
So yeah, that's kind of.
Then I have one more thing I want to ask you about. Then, did you see my thing on the survey about I should be able to search I think that search could be given a huge overhaul to make it a lot more useful. Because a lot of times when we're doing search, you're either searching a name of something, which means you probably already know what you're looking for, or you're doing like this whole like the searching annotation that we talked about a little bit.
Well, sure, you already know what you're looking for, but you don't know the lemmas around it. So like you want to look the lemmas of NB, for example, right? And do some rewrite.
So what I think we should be able to do is I think I should be able to do like search and then provide one of my hypotheses or provide like my goal or something like that. And then I want to, then I can see all of the lemmas that work for this.
Mention parts of this goal. That'd be nice.
It's super great for like a bunch of reasons because one, it's now I don't need to worry about this whole like, do I actually have the syntax right? like when we're talking about notation, like this tricky part of making sure you've constructed your syntax in the right way that it matches whatever pattern it's looking for. I mean, it's almost like whenever I'm doing search, I'm always looking for whatever lemma or something applies to a hypothesis or a hypothesis or a goal. So that's like 90% of my uses of search as a learner of Coq is doing something like this. And then I had something else and I forgot it. Sad. There's some other reason that search is also that doing search like this is super cool. Oh yeah, is that sometimes when you especially when you have some of these notations that are overloaded across different contexts, like you can give plus or something like this, or like one of these like the or like a less than operator, and it's going to give you like all uses of less than or plus in like across everything that you have, and that's then you're gonna have this giant list, and you have to like, if you know what you're doing, then maybe you can kind of thin it down a little bit. But when if you're doing search on like some kind of hypothesis or a goal or something or a goal like this, Coq knows what scope this is being used in, like the nat scope or the string scope, and like all this kind of stuff. So it should be able to on its own thin down the list of results it gives me without me having to go and like continuously craft my little search pattern and make sure I actually know like even just like knowing as like knowing as like a learner, like what is like this whole like percent nats, it's like percent nat scope, but like every different iteration of these has like a different name. Like, how do I even find that name if I don't know what the name is? Like, where do I go looking for this, I think there's all these like little things that are just like they're not even like they're not impossible to overcome. They're things that are doable, but it's like all these little things that add friction. And like I
Yeah,
think that if you provided like some super search thing, like a super search on like this goal or a super search on this hypothesis, you could reduce a lot of the friction that like a new program would have without like breaking anything or ruining the
right.
experience.
Dude, I was watching a talk the other day on a workshop, and people there would use Lean, and I was seeing all this really nice automation and search and and patterns for Lean, and they have some really amazing tooling around this stuff. Like I don't remember what IDE it was, and I'm gonna try to find the video that I was watching to share with you guys. But I remember that this person was showing how he would hover his cursor on some definition and or on some like token, some name, and it will already like show a pop-up, a little pop-up thing with the definition, and then you could do some key bindings over there, and then it would show what are the lemmas involved for this definition and and those stuff. Like there were other really amazing cool things about Lean as well that I don't remember right now, but I feel like there is definitely a lot of room for improvement in Cog that it would be really nice to have. Often enough, I feel like Cog is too much of a research framework, right? Like it's research language where like it's just being developed on what are the cool type system or the cool stuff and not really worried about the usability. Well, sure, no, I don't. By no means, I want to say that the Coq developers are not putting any effort into this because I know they are. But my point here is that it's not their priority, right? They have other priorities. They have to still publish papers. They still have to go through whatever bureaucracy they have in France and usability and this tooling behind to make everyone's life easier is not the biggest priority, right? So I don't know. What we need is more money. I think that's what we need because if we had a lot of money, you could just like hire a person and say, okay, you are gonna make the most amazing search tool we ever had, right? That would be really nice. I was actually talking with one of the guys really involved with Cog, Yves Pierre, Yves Berthaud, and he was saying like anyone can actually donate to Cock and push towards their needs. I think. it's kind of open
kind of like
source in a way right now. I'm not sure how open the development process actually is, but I know that the Coq community is open to receive contributions in every end, and somehow they're open for conversations.
It's kind of like
and
a catch-22 though, right? In the sense that if you need more money to write better documentation and tooling to attract more users, but the only way you can get more money is by having more users, right? So
Is
you
it
end up in
though?
this cycle of
Is it though?
users
Why do you need
give you
more
more
users
money.
to have more money? You just need one really big and wealthy user. What's wrong with that?
Okay, true, but you're more likely to get this, get this big wealthy user like this company if this company has a
Many,
whole bunch of people that they can
Not
hire and they're
really.
interested
I
in
don't know,
working with
man.
it.
People can be really driven by hype. So there's this really huge mathematician that comes up and say, "Hey, Coq is the future and it's gonna be revolutionary," and convince all these people. Like Elon Musk. Imagine if Elon Musk comes tomorrow at Twitter and is gonna say, "Coq is the future of making sure our cars at Tesla are not gonna break." Dude, really? Coq would have so much money, billions of dollars like that. Tomorrow we would have this amazing tooling for the search and all of that. I guarantee you, it's all about the hype.
Yeah, but isn't Cock like 30 years old at this point? The chance of hype is kind of low compared to all these great newcomers that are coming,
Nah,
like
no, dude.
Lean
Let
and
me ask you
Isabel
this
and
question:
Anna.
how many podcasts do you have about Coq and all of this? One active right now. It's this one.
Okay.
So we're not hyping enough. That's my point. If we have more podcasts and video, we don't even have like YouTube channels for this stuff. Like this is really niche, and people who are interested in talking about this stuff is not getting out of their shells to advertise this amazing world to the outside. Or maybe we're just like stuck here in our echo chambers convincing each other, and there's not that much. There's less, like it's less valuable than we expect. It's a possibility, which I really do not believe in, because there are many grants being given to this sort of research. I believe it's a really good time to be doing programming languages research, because the institutions that are giving money and gives grants, like DARPA and even US Army and INRIA in France, like all over the world, all these institutions realize the value of having like base research for computer science, which is what we do here. We're doing base research for one of the most, it's pretty much the most important science that we have in the world right now. Everything is a computer, everything is a code, right? But again, we go back to my original point that our field is always the most important.
Right.
Look at us, we're so cool.
Yeah.
Anyways, I think we have talked plenty. I still have to edit. I don't want to make this another 3-hour episode. That's really, really tiring for everyone. And I think we covered all the most important topics that we wanted to cover. I think it was a really nice and insightful episode. I'm really glad that you guys could come here. I'm really glad for everyone who did the survey, so that we got a lot to talk here. I'm really glad that the listeners came to listen to us. Thank you so much for your audience. Make sure to go to the website and give your thoughts a little bit. Like, what are your thoughts on the hardest thing when you were learning Coq, or what would be your suggestions to make Coq, not only Coq, but interactive tree improvers in general? I'll be very interested to know. So thank you so much, you two, for coming, and I hope you guys can come again in the future.
Thanks for having us, Pedro.
Yeah, thanks for having us.
I hope you guys enjoyed this episode as much as I did recording it. If you are enjoying this podcast, please make sure to share it with a friend. That's the best way to support our show, because we're not taking much out of it. Don't forget to leave a comment in our website, typetheoryforall.com. What are the tools that you would like to see implemented in Proof Assistants? What are the pain points that you think still exist and learn how to use them? You can also share your thoughts on Twitter. Just make sure to tag us at DT4All. Or if you're shy and you don't like, all this noise of social media or putting your name on some comment, you can always send a comment directly to our email, typetheoryforall@gmail.com. That's it for today. I hope you enjoyed it. I'll see you next time.